Hello, today I'm going to discuss triangle congruence, but before I list the different postulates and theorems, I'm going to do a quick review. So the symbol for congruent looks like this, and that is used when I am shown a figure. So for instance, down here, if I'm showing a figure here, that's when I want to use congruent to describe the sides and the angles. So for instance, I see that according to what I've written, I see segment FH is congruent to itself. So that's reflexive. I also see these are angle symbols, that angle E, oops, let's follow directions, EHF is congruent to GHF. Notice I have to pay attention to the directions so that I can see what position is where. And those positions should correspond. Correspond means it's going to match up or it's going together. So you'll see that word sometimes, corresponding. And also, I want you to pay attention to symbols that are shown. I just mentioned that this is a line segment or segment. This is the angle symbol. Above, I showed you the triangle symbol, which tells you the name of the triangle you're working with, because there are two triangles here. So it tells you those two triangles. It's really three if you look at the big one as well. But we're just worried about what's given. And then also, this is called a tick mark. And you have to pay attention to how many are shown because that tells you which side corresponds to which. So just because I see a tick mark, it does not mean that all the sides go together. This is telling me that side EH goes with side GH. Notice I did not say EHHG. The order does matter. So over here, I showed you if I were using numbers, I would actually drop the symbol for the line segment or segment. And I'm just going to say EH is going to be equal this time to GH. So I would use numbers in that instance. So let's just put a number here. If this was 15, then therefore this will be 15 because the tick marks are telling me, it's telling me those two sides have the same measure. And for FH, that if you could see it better if you took those triangles apart. So if I took the triangles apart, F would still be on top for both triangles. E is here, H is at the bottom for both, and G is on this side. So what it is telling me is that F of H is going to be congruent to itself if I took the triangles apart. So therefore, that's why I can write this statement. And I could also set them equal to each other if I knew the value. If I said, for instance, that this was, I don't know, 10, then I know that I would have a 10 on one side and then whatever the other value is. It's not 15, like I mentioned a few minutes ago for EH and GH. I also can see that if angle H, and I have to be careful when I say angle H because I do have two triangles. So I'm going to have to use three letters here so that it's not confusing which triangle H. Which angle H. So if I'm looking at triangle GFH, I want to go follow the directions as it's showing me, GFH. It's telling me that that's going to be congruent to EFH. Again, order matters. If I did not have those diagrams shown there, then I would just have to look at my statement and then look at it that way. So I see E is first, G is first, H is third, H is third in both. So that is going to matter. I just can't stress that enough. Something else that's not shown that you would need to know are arc marks. So let's just say that I had a triangle here and another triangle, and they're not shown that, oh, that's not a good one. They're not facing the same direction. They're twisted where you have to rotate them. Maybe I'm telling you that this angle actually goes with this angle, and then this one goes with this one. How do I know? Because I'm looking at what's called an arc mark. And like I said, the arc mark is kind of like the tick mark. The tick mark is what I was just referring to a few minutes ago over here. That's a tick mark. And for your arc marks, they go with the angles. You have to look at the number of arc marks that you see so you'll know what goes with what. So for this one, A goes with B, and then C goes with D. How do I know? Because C and D both have 2 arc marks. A and B only have 1. So pay attention to that. And I already mentioned that about the 90 degrees. That tells you you're dealing with the right triangle. And it also tells you that the other side is also going to be 90 degrees because a straight angle is 180 degrees or linear pair. Don't forget your measure if you're, I can't remember if I said it already, so I'm just going to repeat it. So if I'm talking about the angle and I'm using an equal sign, make sure you put an M in front of your angle. And if I'm talking about the line segments, drop and it's equal, I'm using a number, take away the segment sign. All right, moving on to what the video is about. Postulates and theorems. So the ones that we're going to talk about are side, 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 which is abbreviated by SSS, side, angle, side, and then angle, angle, side, and angle, side, angle. And we also have one known as hypotenuse leg, okay? So all of these are going to use what's known as CPCTC. Well, what does that mean? That means corresponding parts of congruent triangles are congruent. You're going to need to know that when it's time to write your proofs. So for when you're trying to, if you don't have a list and you just want to kind of memorize which ones are triangle congruent, what I do is set it up this way so that both S's go together, both A's go together. And then I know for the first one, it's just all S's. So side, side, side. For the second one, I'm spelling the word as. So AS. And then when I go to my next one, which has both of my A's, I'm also spelling that same word, AS. And then after that, I'm just going to flip my A and my S. So that helps me to remember it. And then this is just a lone wolf. That's the hypotenuse leg. And that has to be used with a right angle triangle because a right angle or right triangle has a hypotenuse. All right, so let's go through these examples real quick. I've given you a couple of ways that you might see it, but of course there's more ways out there. Again, if I did not know about these tick marks, I wouldn't know what that meant. So tick marks is telling me, so that side and that side is going to go together. This side and this side is going to go together. And this side and this side is going to go together. So what I have in one triangle, I have to have in the other one. What did I have? I had one side that was congruent. I had another side that was congruent. And then I finally had a third side. So side, side, side. If I look at my other figure, I see a tick mark where those two go together. I see where these two go together. I don't see my third marking. However, I should know that if I were to take this, well, this line is reflective over itself. And I demonstrated earlier, if you took it apart, it's going to share the same side. So even though it's not shown, it is understood that if I took this apart, me and my drawing today. All right, if I took that triangle apart, this is going to be a tick mark, and so with this one. So therefore, I could say that it's side, side, side. For example 2, I see, and it didn't, you notice it didn't start with one tick mark. For some reason, it started with 2, and that's okay. So I see one side. And now I have to go in order. I have to what's known as consecutive. So you'll see that word as well. So consecutive, so you'll know what I'm referring to. I can't jump from this side over to this side. I have to look to see whether or not there's an angle somewhere. In this case, there is. It's not marked by an arc mark, but there's something called a vertical angle. Vertical angles are angles that are across from each other. They're not next to each other. Next to means adjacent. So this would be next to. There is an angle there, even though you don't see it. So we want the ones directly across. The way I see it, it looks like an X. And I'm just going to show you the one on top. It also sometimes looks like a V. You see a V right here? And then an upside down V. Well, those are vertical angles, and these are vertical angles. Notice I did not put the same arc mark. So one arc mark one arc mark across, and then double arc marks the other way. Those are vertical angles. And it's where the lines are intersecting, like I said. All right, so now I see if I'm going in order, I have a side, I have an angle, and then I have another side. See that? So that's side, angle, side. If I look at my other figure, I just have to remember, again, this is an instance where I share a side. So I'm just going to go ahead and put one tick mark there. So if I took that apart, I have accounted for both triangles having one tick mark. So again, that's going to be my side. And then this time I'm going this way for this triangle over here, side, angle, side. And then for the other triangle, side, angle, side, side, angle, side. It has to be in that order if it's side, angle, side, okay? Let's go on to example 3. And for this one, again, I only see 2 marks. So I have to know that, oh, okay, these are vertical angles. However, I already have 1 arc mark, so I'm just going to label it with 2 this time because I don't want people to assume that this angle is the same as this one. You can't just make that assumption. You can make an assumption about the vertical angles because that is true. All right, so now in the correct order, if I tried to go this way, that would be side, angle, angle. Well, we don't have a such thing. There's no postulate or theorem that states that. But if I'm going from inside out, I have angle, angle, side, angle, angle, side. So remember the second column, I had the A first and then it spells AS. So there we go. Now, but it has to be true for both triangles. So angle, angle, side. Works, right? So let's do the same thing over here. This time I see a side. I don't see anything here. I don't see anything here. So I can't just jump. It has to be consecutive. I see vertical angles here. But again, I already have 1 arc mark. So I'm just going to make that 2. So I see a side. I see an angle. And then I see another angle. But I went backwards. You can't do that, right? This is what I did. Was that in my list? No, that was not. So now, but I did notice that I had 2 A's and an S. So now I'm just going to write it the correct way. So angle, angle, side. And again, you have to make sure that is true for both. Angle, angle. Did this have a side? No, it didn't. And it has to be in order. So that means I'm going the wrong way. So let's go here. Angle, angle, side. Did that make sense? I hope that made sense. So both of those are true angle, angle sides. Let me just go ahead. You just have to know about your vertical angles because they will not always be listed or shown, I'm sorry. So example 4, what I'm looking for this time is, and it doesn't matter which order in this case, I see an angle, consecutive, I see a side, and then I see an angle. Well, that's one of my postulates in my theorem, right? Or theorem. Angle, side, angle, and I can just clearly see it's the exact same thing in the next triangle. Has to be true for both triangles. Looking here, I see a reflexive side, a side that's congruent to itself, and then angle, side, angle, or I could have gone the opposite way. It's still the same thing. And that's going to be in the same angle, side, angle, the same order in my other triangle. I'm good. And then finally, the last example, it has to be a right triangle. Sorry about that. How do I know it's a right triangle? Because this symbol, I cannot assume. However, I don't see the symbol over here, but I know that it has to be, and I'm not assuming, I know it has to be 90 degrees because again, it's a linear pair. A linear pair has to equal 180. This symbol tells me 90 degrees. So 90 degrees plus another 90 degrees is 180. This side happens to show me both because they're not next to each other. They're not perpendicular or adjacent. So I would have to rotate this figure in order to match them or have the corresponding angles on top of each other. So what I'm looking for is the side that is directly across from my 90-degree angle, because that is known as my hypotenuse. And then I need a leg to be congruent as well. Well, it's understood again, that this is reflexive over itself. So if I were to take those triangles apart, I would actually see that there is a tick mark there. So it's understood that this is a hypotenuse leg. If I look at my other one, the same thing, but this time I'm going to use a double tick mark because the one tick mark is already taken, which is identifying my hypotenuse. How do I know it's my hypotenuse? Because it's always directly across from that 90-degree symbol. If you don't see that 90-degree symbol, then you do not have a hypotenuse. You cannot make an assumption. Like the video and subscribe. Have a great one.